Okay, page 33, repeated roots. So when you have a single root, it crosses the x-axis like a straight line. So that's this first one. That's also a single root. When you've got a double root, it touches the x-axis and bounces back, just like a parabola, like the vertex of a parabola. Okay? So it touches and comes back, same side. So that's double root. If you've got a triple root, it comes in and then does a horizontal point of inflection and crosses like that. So it goes down, flat, and then across the other side. Here's another double root. Okay, if you've got a root of multiplicity 4, so imagine if you've got a power of 4 factor. Okay, it looks like the double root, except it comes in a bit sharper, then it's flatter. It's flatter and then goes back out. So it's much, much flatter here. But just like the double root, it doesn't cross over to the other, the sign doesn't change. Okay, it touches and then goes back the way it came. If you've got a power of 5, it comes in even flatter than this guy and then sharp. So that would be like a power of 5. Okay, and so forth. All right, let's do a couple of examples. Sketch showing all important features. So let's go y-intercept, set x to be 0. So if x is 0, we get y is equal to, that'll be -1 squared times -2. -1 all squared becomes 1. So that'll just be y equal -2. Okay, so x-intercept, set y to be 0. And if you set y to be 0, I'll just go straight to the answers. You'll get x is 1 and x is 2. But the key thing is, because of this squared here, I know x is 1 will be a double. It'll be a double root. Okay, next, leading term. The leading term here, let's have a careful think about this. If you expanded this guy out, because there's a squared there, that would be x squared times x. The leading term will be x cubed. That's positive x cubed, so it'll start there, finish up here. Okay, so let's use all this information to graph a polynomial. Try and draw it nice and big. X is 1, x is 2, and y-intercept of -2. Okay, so we're going to be now double rooted x equal 1. Okay, so convince yourself we're coming from down here. Double rooting at x equal 1, so therefore touching and bouncing off just like a parabola. Then I need to do a turning point because I need to come back at an x equal to 2. I need to go through the x-intercept, and it's a single root. So just go through like normal. And you get your cubic shape like that. Don't know the exact y value of this turning point here, but that's okay. So that's the kind of graph that we need to be able to show for that type of question. Alright, let's do this one. This one's interesting. Okay, let's go y-intercept, set x to be 0. And if you convince yourself if x is 0, that's going to be 0 cubed times all this. It's going to be 0 anyway. Okay, so the y-intercept is 0. Let's go x-intercept, set y equal to 0. So we're going to get 0 is going to be an option. And because it's power of 3, that's going to be a triple root. -2. And because there's a power of 4, it's quadruple. Now this guy, if you set this guy equal to 0, we need to see if there's any solutions to this guy. So x squared plus x plus 1 equals to 0. if you work out the discriminant, you can quickly see if there's any solutions or not, any real solutions. So 1 squared minus 4 times 1 times 1, that's -3. -3, so it's less than 0, therefore no real solutions there. So that means no x-intercepts from that bit. Okay, so I've got my y-intercept, I've got my 2 x-intercepts there. Last thing is leading term. Okay, I've got x cubed there. That'll give me an x to the 4. So far, I'll just write them out. And then this guy here, the highest power of x is x squared. And all the coefficients are 1 there. So the leading term is going to be this, which is x to the power of 7 plus 2, 9. Okay, it's an odd power, positive, so it ends there, and odd starts and ends at opposite ends. So the graph should start and end like that. Let's draw our graph. I'll try and draw it a little bit neater. X, Y. Okay, 0, -2, -2. It's not a lot of points to know, but that's what I've got. We're starting from down here, next to the 9, very, very sharp. It's quadruple, so power of 4. It's going to be like the even one, but very flat. More flat than a parabola. So then it's going to look like this, and then we're going to have to come back. We're going to have to start coming back. And then for the 0, it's a triple root. For x equals 0, we've got a triple root, so it's going to look like just like an x cubed graph, horizontal point of inflection there. And then very sharp because it's power of 9. So that's what my graph looks like there. Alright. Next one. Alright. Let's go. Y-intercept. Set x to be 0. So if x is 0, it's -2, -2 all squared. 1 to the 5, -1. Simplifying this, -2 times 4 times 1 times -1, which is 8. Just be careful with negative signs there. Okay, -2 all squared becomes positive. And then we've got negative times negative, give you a positive. So y-intercept's 8. X-intercepts, okay, if you set y to be 0, okay, -2 can't be 0, so that's gone. So we've got x equal to 2, and that's a double. We've got -1, and that's root of multiplicity 5. Okay, root multiplicity 5. And then I've got a 1, which is just a single, okay? Alright, so now leading term. Okay, it's going to be x squared, it's going to be x to the 5, it's going to be x to the 1, and there's a -2. So -2 x squared times x to the 5 times x to the 1, which is going to be -2 x to the 8. So it's a negative even, so it's going to start and finish same side and negative, so down, down. Okay, so I think I've got enough information to draw. Okay, y equal 8. It's the y-intercept. Okay, -1, 1, 2. Okay, and x to the 8, so very, very steep here. Very, very steep. Okay, let's go. So -1 is a root of multiplicity 5. If it's an odd, so we're going to go from negative to positive there. Okay, and root of multiplicity 5. So just like it's going to be a horizontal point of inflection, but very flat. It's like root of multiplicity 3. Got to go up through that 8. We need to start heading back. 1 is just a normal root, so we just go through that normally. Then I need to kind of head here. 2 is a double root, so I'm going to need to. It's going to look like a parabola, and very steep because it's power of 8, leading term power of 8. So that's what my graph looks like there. Very interesting looking graph. All right. One last question. I've got 2 polynomials there, P of x and Q of x. For what values of x is P of x greater than, the letter here looks, I'm going to change this guy to G of x, okay, so that it matches the letter. For what values of x is P of x greater than G of x? Well, step number 1 is this guy means the same as P of x minus G of x greater than 0, okay. So what I'm going to do is I'm going to form a new polynomial, which I'm going to call f of x, to be P of x minus G of x, and that's what I'm going to focus on. Okay, so let's work that out. Okay, expanding. That's plus 2. Be very careful with the negative expansion there. That guy will cancel. We'll be left with x cubed minus, there's no x squared, minus 3x, and then plus 2. So really this question here means I just care about where is f of x greater than 0. Okay, so I want to factorize this guy, okay, because if I want to solve this inequality, I'll want to factorize and graph. To factorize this, we look for potential solutions, zeros to this. So plus minus factors of the back term. Okay, if you actually sub them in, what you notice is f of 1. If you sub in 1, you get 0. And also if you sub in negative 2, you get 0. Okay, so the roots are 1, negative 2, and I don't know, let's call this guy alpha. To work out alpha, we'll use the sum of the roots, but be careful, remember there's a 0x squared there. So sum of roots is minus b on a. Here, b is 0. So 1 plus negative 2 plus alpha. Okay, work it out. Alpha is going to be 1. So we've got a double root at 1. So f of x is going to equal to x minus 1 all squared, and then x plus 2. There's my function, and it's monic, so 1 there. Okay, so if you're sketching that quickly, 1's here. And I only care about where this graph is greater than 0, the height greater than 0. So I'm not even going to care about the y-intercept. I just want to sketch this guy. The leading term would be x cubed. Okay, so start here, go like this, and a double root at 1. So it'll look like that. So now be careful, but you have to be greater than 0, so you can't equal to 0, so that has to be an open circle. That has to be an open circle because we have to be greater than 0. It'll be this section and this section. Notice that's 2 sections, so right, my answer is 2 inequalities. So it'll be x between 1 and negative 2 unioned with x greater than 1, and that's the answer. Okay, I want you to work on 2.6, and I'll see you in the next video.